Yes, you can, but that's probably not why you bought it. So I don't have a good answer for that specific use case, but there are numerous such examples. And in some cases where we have direct influence, so for example, if we have to optimize Windows, probably a bad example, but we can work directly with Microsoft. Some of our teams have source code level access to Windows. So many times we actually run proofs of concept within Intel, and we show Microsoft the benefits of what would happen if they were to implement things differently. With other companies, also we try to do the same, but depending on which company we are interfacing with, sometimes this process is slower than others.
Yeah, it's probably the drawback of a community development as well.
Sure.
Yeah. Okay. Thank you.
Sure. Any other comments or questions? Okay. So I've already talked about how we are contributing here, so I won't belabor that. There was a question you asked about what we are doing. So we don't have our own distribution anymore, but we do have partnerships. For example, we actively collaborate not just with Cloudera, but Hortonworks, MapR. Our goal is to grow the TAM, because for whatever reason, if you're an enterprise customer, you may prefer one distribution over another. And our goal is, as long as the customer is happy with running Hadoop via one distro on standard general purpose Xeons, we are good. For the same reason, we don't really have a preference in terms of which Linux distribution you run. If you are a Red Hat customer, all power to you. If you prefer Ubuntu Canonical, that works for us too. Where we do influence these deployments is we actually actively work with the ISVs. So for example, we have, as I mentioned, Microsoft as an example, but we also have collaborations with Oracle, for example, for their DBMS, with SAP HANA. So we contribute code that makes HANA run well. So we have all of those kinds of examples for tuning software on IA. Okay, this is a little bit of a stack chart, if you will, and the idea is to illustrate where Intel plays in terms of our contribution. I realize maybe the hardware here is interfering, but these yellow boxes or this mustard color box is intended to depict the TLPs in Hadoop where we contribute. And that's the area where we have community partnerships, participation, and as you can see, we have PMCs in this, and in many of the other areas. Okay. We had a lot of discussion about Spark yesterday, iterative in-memory computation. Sentry is still being incubated, but we have a presence there. Okay, this is probably awful if you are even in the third or fourth row, but my objective is not to walk through each and every line here, and I'm not trying to sell you Intel's product segment. What I want to draw your attention to is this red rectangle here, and again to your point, this is where Intel's what we consider efficient performance or two-socket platform. So this is the standard general purpose Xeon platform that makes up a bulk of our DCG group's volume and revenue on an annual basis. So this is the platform that typically is used to deploy Hadoop. The expandable range is typically what we consider a scale-up platform. That's our top of the line Ferrari, if you will, and it goes to a large number of sockets. Tremendous amount of memory, but slightly pricier. So Hadoop installations typically run on the EP model I mentioned here. Okay, so this is a public-facing foil. I'm aware that this whole presentation is going to be posted. So I'm at liberty only to show what's already launched, and 2015 onwards is indicative. But I can talk a little bit to it without going into specifics. And as you mentioned, sir, you have sometimes this hardware engine underneath which is semi-utilized or underutilized. But our hope is that as installations and as software people can tune and configure it, we can optimize it. So we keep growing the number of compute cores with hyperthreading that keeps increasing. Increasingly, IA is getting more efficient. We are able to deliver better performance power, better performance per dollar per watt, and all those metrics that you're familiar with. The third sub-bullet is actually particularly exciting. So going forward, again, I cannot reveal timelines and which projects and so on, but we are going to see a substantially large memory footprint in the segment I showed earlier. So again, without going into specifics, just think of what Spark could do if it had, I'm going to make it up, twice as much RAM. And I'm talking about standard DRAM. So you're not doing anything funky in your platform. The same general purpose Xeon based hardware that you deploy, it just comes with a bunch of RAM that today doesn't exist. What if you had that capability? Seems nice, but it's particularly exciting for Spark. It enables, in my opinion, lesser I/O up and down the network. You can do more within the same node. You can do more iterations. It starts to approach HPC-like workloads. We are also going to have customizable on-die capabilities. So for the right customer, for the right workload, we are able to offer on-die, so in the package, we are able to reserve space. So you can bring your workload, you can bring your accelerator, you can bring your design, and it will coexist with the rest of the compute cores in a cache coherent manner, so that your workload has access to the same memory data that the cores do. So again, cannot say much more beyond that, but if you had a workload that would benefit, for example, from a proprietary algorithm, you could bring that and it could be deployed on Xeon itself. We talked about networking. We've already delivered 1 billion plus ports so far, going all the way back from 10 Mbps Ethernet. We're looking at speeds 40 gig and well beyond that. So some of you probably heard about our initiatives in silicon photonics, right? So this is not just that. This is just faster I/O. And there is an increasing amount of technology integration happening. So in the current and prior generations, you've had capabilities where you had technologies in discrete form. So you had to plug in, for example, a PCIe card in your platform. Coming soon to a server near you, you'll get these kinds of workload accelerators, and we'll be able to provide these frequently on die inside the same package. And obviously for Hadoop workloads where you need encryption, where you need some amount of compression, you can expect tremendous performance benefits from there. Okay, I'm going to go over this relatively quickly, but please stop me if you have any comments or questions. So yesterday we heard about, hey, we had mainframes, we have huge RDBMSs. What we are finding is that in some verticals, healthcare or retail in particular, that the data sets are now so large that they don't fit into any single system or an RDBMS, even those large scale-up systems that we talked about earlier. Now, customers have already invested a lot of money. They have bought the hardware, and they have those installations. They have expertise. They have people who are skilled at SQL. You can't just throw all that investment away and start from scratch with Hadoop, because that's the next wave. So we are seeing a lot of interest in using Hadoop as a data lake, yes. So keep all of their data in its native format as a raw repository. So you keep all of the data there, but at the same time, figure out a way to mesh it with the rest of your incumbent systems here, all the typical Oracles and the HANAs. Now, there is probably some value in keeping the hot data in those systems and move your warm and cold data to Hadoop. So that presents like a two-tier approach where you have data tiering. So you can't just delete your sales data from, say, 12 years ago, because you might have a lawsuit that requires you to pull that out. You might have an audit, or you might have some other needs. So we are seeing a bunch of interest from customers who have data sets today of 450 terabytes or even larger, and they want to be able to archive and tier that data across multiple systems. And yes, so the notion of which data is hot, which is warm, and which is cold. HDFS initially probably designed to work very well with a small number of very large files. But as Hadoop is starting to get deployed, we are starting, and Uma is actively working on this. Customers are saying, that is great, we also need that, but our main interest now is, can you please support a very large number of small files? So I think 1 billion, 10 billion is easily the goal here. And I'm not sure if I heard it right, but yesterday there was mention of 1 trillion files that I think either Mapar or somebody else is targeting. So there is significant customer interest to go beyond the initial promise of HDFS into supporting these kinds of features for which it was not designed earlier. So these are some of the trends we are seeing, and I want to open it up if you are seeing something else or you have any other comments where it's going. So if you have a mic, can we go to that gentleman over in that row?
This is a different question. It's a hardware question. Last year when I was attending one of the developer summits, there was one gentleman who talked about an emerging technology in the RAM space. So today, when you switch off a typical computer, the RAM goes off, right? You load everything back into the memory. So he was talking about a resistive RAM technology, which could, which doesn't need any boot, and you could store your entire thing in memory, right? So that could completely change what you're talking about now, right? It's a completely new thing which is going to come. So how do you see that coming up and changing some of this landscape?
Great question. And so this bullet, again, these are public files, so I have to be a little careful in what I say, but I'll just say that another compelling feature accompanies this large memory footprint. And HP has made a lot of noise publicly about memristor technology. That's probably what you're referring to. And all I can say is we are not sitting idle. So we are very excited that we can offer something very, very competitive, if not better. Absolutely better is what we are targeting. And that's why it makes sense, right? I mean, if you have, I'm just going to make up some numbers here, but if you have a 12 terabyte DRAM system, today we think of 12 terabytes as hard drives or SSDs. But what if in that pyramid hierarchy of storage, where the CPU cache, the LLC, is at the very top, meaning it's the smallest, it's the fastest throughput, lowest latency, and highest cost, because it's in package. And then the next level is your standard DRAM, DDR3, DDR4. The Haswell platforms we launched last year are DDR4. So as the memory footprint goes from whatever number it is today, 256, 512 GB, which is still pretty decent. But what if you change the game and you take it all the way here and say, now we have tens of terabytes of DRAM. Now all the present models break, because when these systems boot up, right, BIOS has to do an MRC, and that MRC check itself could take 5 hours. And it's a good thing that servers don't get rebooted like these puppies do. But they still need to be brought down for maintenance once in a while, and a 5-hour boot window is simply unacceptable. So not only are we aware of this, but as we grow the memory footprint and as we grow the adjacent feature set, we are also working on making sure that those things are addressed. Unfortunately, I can't say too much at this point publicly. We are about a year and a half from that in production, but people are hard at work on that. Okay, and actually some of this is in the public domain. I'm just being very conservative. Maybe if you Google things, you'll find a little bit more. So it's not that I don't know what else is going on, but I'm constrained in what I'm willing to say.
Yeah, my question is with respect to the data tiering and data archiving which you had kept. So in general, any storage, be it NAS storage or SAN UC, it would have the inbuilt, OS would have the capability to do the data tiering or archive, okay, with respect to the policies which they put in. So how different is that Hadoop is going to help in that? And one more question with respect to the same thing is that sure. If you see the trend is that considering the archive storage, especially these days, there's a lot of Facebook and YouTube, and these videos are being archived for a long period of time due to their legalities. Now, the trend which is going to come out would be like things like tiering to cloud, and it's because due to the dollar per gig going down. So will Hadoop be able to help in that kind of a aspect?
It's an interesting question. Let me take the first one first. So in this context, when I'm talking about data tiering and data archiving even, I'm referring specifically to the seam between Hadoop and the other RDBMS type systems. So you're right, the concept itself is not new. I mean, data tiering has existed for a while. You can have data tiering within a system as mandated by your software policy or OS policy. But in this context, what I'm referring to is customers want to mesh together two different disparate type of systems and have data, unfortunately spill is the wrong term, but spill across both. And the ability to be able to recall data that's archived somewhere deep within HDFS and bring it back, decrypt it, and maybe you want to run some reports or BI on that. So these terms I'm not claiming are new in this context, but they are what customers are asking in terms of the RDBMS and Hadoop integration.
So does this reduce the time to retrieve? Because that is one concern when we use the inbuilt OS.
Yeah, good question. I am not sure it will reduce the time. I think the first step is to make sure that the integration is successful functionally, and once it is working as expected, right, then obviously we'll work like hell to tune the heck out of it. So when I say functional correctness, a lot of these DBMS systems will allow you to or support encryption. And if you are, for example, if you are running Cloudera, Cloudera has two different modes, or CDH offers two different modes of encryption. One is a client-side encryption with the Navigator product, and one is the encryption that's native in HDFS. So if the RDBMS is talking to the Hadoop installation and they understand that data is encrypted, then at the very least, those two schemes have to interoperate with each other. Because if that doesn't work, no matter of what the performance is, it's not going to help you. So the first step is to make sure the seam works, that you are indeed able to extract the data and process it and then store it back perhaps. So we haven't probably come to the point where we can talk about use cases or white papers that show what performance it is. So it's still early days.
Okay.
Okay. Any others? Any other questions or comments?
It may be a generic question, but can we see one day like all HDDs will get replaced by SSDs? Like
I'm sorry, I can't hear you very well.
no,
If you can.
No, whatever is, hard disk drives. Hard disk drive, which is
Okay.
existing today, it can be replaced with SSDs like fully.
My personal opinion is yes.
So when it will be like,
That's the harder one to say. Because it's like the pyramid of storage I referred to, right? If you look at the Xeons from 10 years ago, the amount of last level cache that they had was nothing compared to what we have today. But today we have SKUs that have 24, 28, 36 megabytes of LLC.
okay.
And I'm old enough that my first PC that I bought had a 20 megabyte hard drive. And that was cutting edge at that time, right? So we've gone from 20 megabytes of a hard drive in a desktop to more than 28, 36 megabytes in an LLC inside the Xeon socket.
At least you can replace HDD like.
And we are. So I'm happy to tell you that I have progressed from those days. My desktop at home now has an SSD.
Okay.
So I'm trying to keep up. But when will it completely make hard drives obsolete? I cannot even hazard a guess. If you were in the other room yesterday, the gentleman from CERN said CERN still uses tapes.
Oh, that's for long-term usage, like.
Right, but they are. If you also heard him, he said they also do transfer data fairly actively from hard drives to tape and back, because obviously tape offers a humongous amount of capacity for the same dollar value.
Yes.
So it's. I'm not going to hazard a guess, but at the current price, Intel is at the forefront. But there are other companies also that are actively working to reduce the cost of solid-state storage, lower and lower. So the price points you're seeing now are much lower than 5 years ago, and so probably 10 years from now you may see the picture reverse, like the Linux versus proprietary Unix chart I showed. You may still have some hard drives, maybe for cold data, maybe for archival, but I think SSDs are going to dominate.
Okay. Okay.
Any others? So I agree with the second part. I'm struggling with what you mean by the first. When you say management tools or.
So for data management, obviously you need the metadata management, integration, other things. So you can enhance your framework. Are you enhancing that framework on Hadoop? So there is H catalog, for example.
Okay.
So that's basic, right? So is there any other enhancements on the metadata management for the data lake?
I'm not sure I know the answer to that. Sorry.
Okay.
So maybe I can try to understand your question a little bit better in the break and see. Okay. Sorry about that. Okay, let me keep moving. So I'm just going to touch upon this because as I was getting, as I was new to Hadoop, one of the first questions I had was, well, we've got products that support the HPC vertical, those workloads. We've also got products that Hadoop runs well on. What's the difference and why do we have two? Well, the answer obviously is that HPC workloads differ significantly from Hadoop workloads, and the kind of emphasis that HPC workloads have on low latency and high performance, right from the interconnectivity to the relatively higher investments that they make in the hardware, distinguishes those workloads from general purpose Xeon based Hadoop workloads. But there are customers that have made those investments already. And as you can tell, right, if you're an enterprise shop, you've invested several millions of dollars. You're not going to just throw that out because Hadoop is the next best thing. So we have several expressions of interest from customers who want to deploy the hardware they already purchased for HPC workloads, yet find that those workloads, even though they run well, the hardware is relatively underutilized. So if you want to run it 24/7 to do something, maybe it's not utilized more than 18 hours a day. So there is capacity in that hardware to run some Hadoop jobs. Unfortunately, those Hadoop jobs don't just run unchanged on HPC hardware. So that's where people like Deva on my team work with